So the Serval project, given that not many of you heard about it, I will talk a little bit about it. So after the Haiti earthquake, I remember the rawness of the moment of sitting in the car and hearing about it and being mindful, as I imagine a number of us are, that when a society loses communications capability, that law and order actually disintegrates within a few days from that. Once the bad guys realise that the good guys can't call each other up and turn up to chase them, the bad guys realise that they can do pretty much whatever they want. And so this is kind of in my mind. I thought, oh look, I knew that the mobile phone network was substantially knocked out. I thought, oh look, they'll be able to fly in gear, and they'll have funky guys in greener khaki than I'm wearing, rolling out big shipping containers and goodness knows what, and putting stuff back together. So I'm thinking this happily to myself when the person on the radio then said, oh, and the airport has been destroyed by the earthquake. There is one functioning runway, and it's taking one flight in or out every half an hour with air traffic control out of Florida, i.e. from another country. So I thought, okay, if I want to make myself feel better that things are going to be okay for the Haitian people, that really wasn't going to cut the mustard. So I thought, okay, well, they can drive in. Haiti, unlike Australia, is connected to another country by road, and so they could kind of, take a little bit longer, but it would still do it in time. Truck gear in from the Dominican Republic and get everything patched up and working again. So I'm, having a renewed sense of having escaped from having to face the reality of what was happening there. When the person on the radio then said, and practically every road in Haiti has actually been turned to rubble. And if you've seen the pictures, they indeed very effectively were turned to rubble. So I'm sitting there in the car thinking, okay, I'm going to have to try harder if I want to, in my rich, white, wealthy position, to find a way to not feel so bad about their situation. And so I remember thinking, okay, it'll take a little bit longer again, but they can fill up a cargo ship in the harbour at Dominican Republic and basically do a 3-point turn around the point and pull into to Port-au-Prince Harbour. I'm thinking, oh, what a wonderful person I am that I can think of ways to not feel so bad about their situation. As I'm thinking this to myself, the person on the radio says, and the harbour has collapsed. And I just remember the rawness of that moment of thinking, all of my resourcefulness about feeling better has been exhausted. And just thinking, being forced to think more deeply about what was going to happen. And just the apprehension about what was so very likely to happen for the Haitian people. And unfortunately, as I had confirmed talking to various relief organisations later on, indeed happened. There was really nasty stuff, and they'd be driving from one hospital to another and go, oh look, how wonderful, a government checkpoint to make sure that we're all fine and safe. No. That checkpoint is not operated by the government. It's operated by whoever it is happens to have a big enough gun, and they just rat through your car and grab what they want. And if your car is better than their car, then maybe they do a swapsy with the car, or maybe they're short of a Hilux, and so you get to drive off in your air car afterwards. So there was all of this kind of stuff going on, and so it just got me thinking, like this does not need to happen. This should not happen. And then I got thinking about, well, why does it happen? And it's this whole, the fragility of communications, mobile communications in particular. And so then I started thinking, totally should never happen ever again. And so, as one often does with grandiose ideas, I initially started thinking, okay, assuming no roads, no airport, no harbour, how can we kind of get phone towers back up? And so I sort of had these great, concepts of, flying C-130 Hercules over Haiti or somewhere in need and pushing out sort of half shipping container things that basically then sort of land on the ground and transformer-like turn into a phone tower and then sort of mesh amongst themselves. And this was a wonderful idea. And the irony is it's probably easy to get funding for something like that in some ways, because it costs a fortune, and the whole industrial complex can make a lot of money out of it. But then what occurred to me, in fact, was we didn't need to. The things that we all carry around in our pockets physically are capable of communicating any way we like. It's only the fact that they are effectively captive, and just the mindset of the carriers is captive to this infrastructure-dependent model. If you think about carriers, they have two natural monopolies. One is on big piles of cash to build stuff, and it's not quite a monopoly, but it's, I don't think any of us here probably have $3 to $4 billion handy to roll out the next open source project. If you do, please let me know. But on the other hand, it's Spectrum and the regulation and the licenses that are the other natural monopoly, and the infrastructure based on that. And so anything which undermines the ability, that undermines that natural monopoly and lets phones talk without using phone towers is naturally of no interest at best to the carriers, and if they're feeling particularly paranoid, is actually something that they would want to stop. And so it's not surprising that mobile phones haven't really been blessed with the means to communicate directly. I mean, in the 20th century we had walkie-talkies and we could kind of yabber away for free and and do all of those wonderful things that we could, and we now have something which is much more capable than a walkie-talkie, and yet we can't even do with it what we used to be able to do with a walkie-talkie. And so some of this is what we're trying to solve with the Serval project, and so we have been getting these phones to mesh using ad hoc Wi-Fi, which has a whole pile of difficulties with it. Partly you need to root phones on Android. iOS doesn't have full support for ad hoc. Windows Mobile doesn't have full support. Symbian does. Unfortunately, Nokia appear to have gone with Windows Mobile instead. And so it's kind of, well, what do we do about this? And so then it got me thinking, well, we should get some custom mobile phones made that have an Arduino in the back of it, and hence we start getting onto the main theme of this talk. And then we can put any radio front end we like on it. So we could, for instance, put a 900 megahertz ISM band, so it's another band like 2.4 gig for Wi-Fi, down at 900 megs. It's free to use in a bunch of countries, including here in Australia. The irony, of course, is the radio and the main phone could actually talk on that band, but extracting the secret information out of the chipset vendors to reprogram that is a very difficult process. So it's much easier to go to a cheap Chinese phone manufacturer. For a few $100,000, we can probably get a phone design that has an Arduino port in the back, and then we can plug whatever radios we like in the back. It's then all open source from that end, and we can start writing the software we need to make use of that. And sorry, yes, a question?
Android already has an accessory development toolkit that is based on Android, that's based on Arduino.
Yes, so the comment here is that Android already has an accessory kit that is based on Android, and so you have a thing that you have to basically plug into the phone. So you kind of, you want to make a phone call, and it's like the magic trick, you're pulling out endless stuff. And from memory, the accessory port has to be powered. The accessory has to be powered. I think someone can correct me if I'm wrong. Yeah, so it has to be powered. So you sort of you pull out the device and then you pull out the battery thing on the end, and then you pull out your cord that's plugged into the wall potentially to run it. So and it is a solution, but the right solution we think is actually to say, well, it's pretty easy to get one of these modified, find a spare SPI interface, attach that to an Arduino, and there's already sort of some open source devices out there, like little OpenWRT routers that have this kind of capability in there. So the technical risks are really low. And so then we can put that in. The Serval Mesh protocols already support using low bandwidth interfaces, so it's just a case of writing the tie-ins for that and doing some optimization and polishing work on that. And we potentially can actually have communications without depending on Wi-Fi, without needing to root the phone. And this is really nice, and the range potentially is 16 to 32 times what Wi-Fi would get with the kind of little itty bitty radios. I think might fish one out of the bag after, but they're basically sort of about 1.5 inches long and let's say 30 mils long and 20 mils wide or so, and about 5 mils thick. They're really quite small. And the other nice thing is that it means that you can change the radio based on which country you're in. If you're in a country with a regime, pardon me, who take issue with you wanting to communicate with your people around you to protect yourselves against militia and goodness knows what, and they start jamming your favourite frequency, well, actually you can just replace the module with a different one on a different frequency. And we're just allowing that innovation to occur. So we think there is tremendous value in that and of itself. But then, as thinking about that, thinking, well, actually, two things. One, we don't really want to compete with Huawei and Samsung and Apple and all the rest of it on handsets. I mean, if, for instance, we got a nice little phone like this made with an Arduino in the back, and you have to pick a price point. So say we go for the lower end to make it more affordable. Who here is willing to use a low-end Android phone as a daily phone? 2 people, 3 people, 4 people. 4, do we have 5? 5 people, excellent, 5 down the back. Sold. The vast majority of you, however, are not. This is totally understandable. So what we realised actually is we can actually make it cheaper again by not making it a phone, but actually just making it a mesh helper device. So ditch the expensive screen, could probably actually go for a slower processor, and put a bigger battery in there where the screen was, and it can operate as a Wi-Fi access point, as an ad hoc mesh node, so it can peer local range to themselves at high speed, and then has the Arduino port, so you can do the long range meshing in there. Sorry, yes?
Basically, like an OpenWRT router with the port for an Arduino, but with a battery.
Yes, that's right. So we're basically talking, like an open word device with an Arduino that is battery powered and can fit in your pocket. Yep, and with the right firmware on it. Absolutely. In fact, the way we're prototyping it is in fact actually with a TP-Link WR703 N $22.3 watt unit. That's actually going to be a really nice way to prototype it. So this is all wonderful, and I think that actually has profound implications. Once we can do meshing over kilometric ranges, suddenly we actually have a really useful capability that I think actually eclipses what CB radios used to be able to do. Because we can do multi-hop, so we can extend the range beyond that, sort of kilometric distance. We can do text, we can do file exchanges. We demonstrated earlier this morning, we can actually update our own mesh software over the mesh using our store and forward file exchange system. So that's all fantastic, and we then realised a step further. When you go to hospitals and clinics and you look at a lot of the various medical doohicks, to use a technical term, they're typically a box of blinking lights that plugs into the wall, that has a battery in it, that has a processor, and probably has some signal processing capability in it, has a bit of a screen and some buttons or increasingly touch interfaces on all of these things. And then it has a port that plugs onto a curly cord that has some interesting thing that they poke in odd places, or put your finger to measure blood oxygen levels and the like. And what we realised actually is if we make this mesh helper device, it's actually not just a mesh helper device, it's actually commoditising the box of blinking lights for a whole class of medical devices potentially. So you might have a $200 tablet with a nice big screen for interfacing to it. You then have the helper device that's plugged into the curly cord that then maybe is monitoring someone's pulse and oxygen levels in their blood. And it can use the mesh, say if we're in a developing country where there's no good network infrastructure in the hospital, the mesh can actually be reporting back to a nurse's station to say, patient N is stable, they're within the alarm ranges of pulse. It can alarm if the mesh communications fails, or if it goes out of alarm levels. And that, I think, actually has profound potential impact around the world. Obviously, in developing countries, it means that instead of a $2,000 pulse oximeter, or actually the cheapest decent ones are about $250, you could potentially have, someone was saying earlier today, you can get phones much like this in Coles at the moment for $49. And then the mesh helper device, I would like to think that it can be under $100, and then you can already buy spare parts for most of these boxes of blinking lights because the curly cords break and the little things on the end break. And so you can go onto Alibaba one day and see all of the interesting medical attachments that you can buy at alarmingly cheap prices in quantities ranging from 1 to 400,000, which is probably not the best way to buy Band-Aids, but anyway. So,
have you got kids?
Yes, we do have kids.
That's probably the best.
Yeah, unfortunately, you've got 400,000 Dora Band-Aids, and then by the time you've got through the first 8 of them, suddenly they want, Buzz Lightyear ones or something. So that's
when you cover them in them.
Yeah, so you need to get them like with those Optima keyboards with the active LED displays, so you can change the Band-Aid appearance for them. And that's a whole interesting marketing opportunity, isn't it? Meanwhile, back at the point of making cheap boxes of blinking lights, so we can probably already undercut the price of the best, cheapest, worthwhile pulse oximeter. And then, with a bit more software development and a little bit of work, we could have a fetal heart rate monitor. You can already buy the spare parts for those for like $30 or $40, something like that. And then you go, well, an imaging ultrasound machine. Well, the big things, if you're having kids or whatever, and they go in and you get to see the kid, and you go, oh, this is all wonderful. And you go, this is an enormous box that must cost a fortune. You go, hang on a minute. It's an ultrasound, like it's an ultrasonic transponder on the end of a curly cord that needs some signal processing, needs a pretty screen, needs some battery backup, needs some way for an operator to input into it. And there's a group in the UK who are making ultrasound probes now for that kind of, that can be used for that kind of thing, for 40 quid. So you go, okay, 40 quid, so what is it, $60 or something, and depending, dollar keeps going up. When you operate on research grants, it's very annoying that our dollar is high. I need our dollar to go through the floor every time we get a grant payment through from overseas. It would be very welcome. So if anyone's into currency manipulation, just let me know. But meanwhile...
You can't build a small device on it, we're building small...
Yeah, so we're trying to control their brain waves. But anyway, so you go, okay, $60 for an imaging ultrasound probe, say $40 for the fetal heart rate monitor, and you go, but hang on a minute, wait, there's more. The imaging ultrasound probe, you could operate it in single channel mode and actually use it as a fetal heart rate monitor. Totally easy to do. So, okay, $60, $10 for the pulse oxy probe. There's a group in India who have just made a pulse oxy heme sensor using 6 LEDs. So no pinprick, and they can tell whether you've got anemia or not. And at the moment that's proprietary. If anyone's interested in board and would like to do an interesting PhD project, I'd love to make an open source one of those. Let me know. Our department has biomedical engineering and us open source mob in the same place. So you go, okay, what is it? So $60, $70, $80 plus, say, $70 for the helper device, plus another, $50 for the phone. Suddenly you've got something that you can hold in one hand that replaces a $50,000 imaging ultrasound machine, a $1,000 fetal heart rate monitor, and a $200 to $2,000 pulse oximeter. Did you know in the developing world that every year 500,000 women die in childbirth for a variety of reasons? Another 500,000 are severely disabled in the process. So basically it's 1 million women a year. And that's not counting the little lives that are lost or impacted in that process. One of the leading causes in that is actually anemia. Undetected anemia. So then when there's blood loss during childbirth, it gets to critically low levels and complications set in. If we could equip every midwife going through deepest, darkest Africa and wherever else with a couple of $100 worth of gear that would let them do a whole pile of diagnostic checks. Even if they don't have the skills to interpret the results, the mesh can carry the data back and synchronize it into the clinic when they walk back into the clinic. So we can carry the data on foot. That is disruptive. That is disruptive not merely economically, it's disruptive in terms of development, of equity of opportunity, of lives. It's disruptive of society in a really positive way. And that is why Arduino enabled phones or mesh helper devices is something that we totally need to see. And we've talked to a few places to actually prototype the hardware of the device. $100,000 to $300,000 to write the software to start using it for the mesh. I don't know if you said of the order of $1 million worth of effort, but with the open source community, we can probably crowdsource part of that development effort and get that cost down. But even if, for the moment, we said it's say $1.5 million to do those 2 tasks, and then those 3 medical devices, the imaging ultrasound would be the hardest one because we kind of need some really clever math bods and some time and effort to do it. But I mean, hey, there's been gazillions of imaging ultrasound machines made in the world. It's totally practicable. Let's say it cost another $5 million to make that suite of 3 attachments that you could make for it. So for a few $1 million, we actually have the opportunity to really transform the way that healthcare is provided in the developing world. And actually I think there's a really good economic argument here in the developed world as well. You look at the number of older people who would dearly love to stay living in their own homes and actually having freedom and quality of life rather than actually being prisoners of society's conscience. We are worried about old people having a fall in their own home. We never, or very rarely actually think to ask them and say, here is the trade-off. If you stay living in your own home, you may have a fall and your quality of life may be curtailed sharply at some point. or we can put you into a supported care where your quality of life in all likelihood will actually be severely curtailed immediately, and let them make that informed choice. It's actually usually fearful medical practitioners making that choice. Sometimes it's fearful family members who are not aware of any alternatives. But the bottom line is, if we could if we could defer the age at which people went into supported care by a year, in Australia and the US alone, it would probably save something of the order of $3 to $4 billion a year. So the economic argument, I think, is actually totally there. Just looking at that, so ignoring the fact that we really have this kind of moral obligation to actually help the developing world and people in rural and remote areas. Who's ever needed to use a flying doctor? Anyone here ever needed to use a flying doctor? People here aware of what the flying doctor service is? Who's not aware of what the flying doctor service is? Yeah, a couple of people. So here in Australia, we are extremely fortunate. We actually have, I think it's officially the world's oldest flying doctor service, because basically we've got, 8.5 million square kilometres, 22 million people. When it was set up, I think our national population was about 4 million people. So it was one person per 2 square kilometres, and most of that, of course, is on the edge of the pie crust around the coast. And so we recognised that we had this need to help people in need in the interior. And I think actually it was 1996 that the US finally got something like this, and we've had it for 100 years or thereabouts now. And it's primarily actually been publicly funded, as in like by the public, not by the government. I think there's a bit of a mix in with that now. Amazing that they can actually get to anywhere in the country in 2 hours. Think about the logistics of that when there's no airstrips covering 6 million square kilometres of the country. But anyway, so I think there is this compelling opportunity. I think a well-structured Kickstarter campaign could totally fund the first 2 stages easily, and then once you have the first 2 stages, then you might hit Kickstarter again, or go to the Gates Foundation or one of these others and say, hey, we can change the world. It's only going to cost this much, and it will actually return a profit in the sales of gear and a massive social profit. So this really is why I think Arduino-enabled phones is a critical thing that we need to do, and we'd love anyone's help that would like to partner in making that a reality with us. Thank you.
Time for questions, so if anybody has a question.
Sure.
What do you think about the Tricorder X Prize?
The Tricorder X Prize, we've looked at it and it looks very interesting, and I think it's the kind of thing that this kind of concept would have the potential to win, although the Tricorder X Prize is specifically focused around having a doohickey that can diagnose, which is actually much harder than just being able to measure and convey the data back to a healthcare provider. So what we're proposing is the low-hanging fruit between here and the X Prize. In actual fact, it's really actually the bulk of the value, I would actually argue, is in getting this first stage, and then having the automatic diagnosis just provides further savings beyond that. Yes?
Probably worth commenting, the whole space of these kind of portable, low-cost, personal medical instruments is exploding. There's every month or so there's a new announcement that someone's produced a new thing that you just hold to your temple and it tells you your state of health, or a new thing that puts on your finger, or so. The chap in India who's done the anemia detection, it's just rolling. So many people are working on this independently, scratching their own itches, or as it were.
Yeah, and so I'm not sure whether that will have picked up on the microphone. So the comment is basically that the medical hardware attachments for phones are coming out at an increasing rate, and so really what we're talking about is pushing the cost of that down, because most of them actually come out for iPhone. The iPhone costs 4 times as much on its own as what we could potentially provide a suite of medical attachments, and it's not really easy for your average person to innovate on the hardware on the iPhone. You kind of need to to do the whole get the blessing of Steve Jobs Ghost and all of that kind of stuff to do it. What we want to do is make a device, it's an open source Arduino based thing. We want people to say, hey, we can make this thing that we think can measure blood pressure, whatever the thing is that it can do. And then they can publish the results of that, and then a medical device company might say, hey, we're going to look at that, we're going to do the rigorous testing, we'll do the certification and get it to market. Or it might be that through Kickstarter campaigns it actually gets done in a totally open source kind of way. I'd love to see health go open source, because the current financially vested monopoly basis of healthcare doesn't work. I mean, you look in the US where it's at its most extreme. In the US, they spend on average, a few years ago these figures are from, 14% of their GDP goes on healthcare. Here in Australia, where we have, I think they would call it a communist, socialist and fascist all at the same time, I think because we have a national healthcare system. Oh, that's right, and we send our grandmothers to death boards as well, I believe, was what the Republicans were arguing as well. Nonetheless, we spend 6 to 7% of our national GDP on healthcare. And anyone who's wandered around the US, I mean, the state of health of people there for what they get for their 14% versus here, particularly if you're not in the wealthy bracket, it works a whole lot better when these things are not captive to commercial interests. The US-Australia Free Trade Agreement, the US health companies tried to get our PBS basically banned, so our pharmaceutical benefit scheme where we subsidise medications. And the reason they don't like it is because we apply a threefold test. The thing has to be at least as good, if not better, than the previous medication in that category. It is like the military thing, so it has to be better accepted, and it has to not cost more, or has to ideally actually cost less. And they don't like competing on the basis of benefit. They like to be able to run ads and convince on the basis of marketing, which is of course a parasitic cost in the whole thing. And the ad part is probably actually counts for 2 or 3% of that GDP alone, I would suspect. I don't have the figures to back that up, but it's my suspicion.
All right, we've actually run out of time for questions now. So, Claus?